Imagine opening a mechanical assembly that contains hundreds, maybe thousands of components. Each component is critical, but without a way to identify them quickly, it feels like searching for a needle in a haystack. You pick up a bolt, a gear, a shaft, and wonder, which one goes where? Which one is compatible? Which one is the correct version? This is exactly the chaos that part numbers solve in mechanical design. Part numbers are not just codes, they are the lifeline of every mechanical product, the silent language that every engineer, designer, manufacturer, and technician speaks. For over 15 years, I've seen the difference between a design with organized part numbers and one without, and the contrast is astonishing. A well-structured part numbering system can make your life simpler, projects faster, and mistakes almost non-existent. What is a part number? At its simplest, a part number is a unique identifier for a component. Think of it like a barcode in a supermarket, but for mechanical components. A part number allows you to specify, order, design, or manufacture a component without ambiguity. Unlike a name, which can be long, vague, or inconsistent, a part number is precise, consistent, and universal. For example, instead of calling a bolt small hex bolt, a part number like B10M8SS can instantly convey B equals bolt, 10 length 10 millimeters, M8 thread size M8, SS stainless steel. This simple code eliminates confusion. Anyone in your team or even a supplier thousands of miles away can understand exactly which part you mean. Why part numbers are essential. Before standardized part numbers, engineers faced chaos. Assemblies would arrive missing critical components or worse, with the wrong ones. Mistakes in design, procurement, and maintenance were common. A gearbox might fail because someone ordered a gear with the wrong teeth count. A simple bolt could hold a critical part incorrectly, causing expensive downtime. Part numbers changed all of that. They brought order to complexity. They allowed designers to organize assemblies logically, make procurement predictable, and maintain equipment efficiently. How part numbers help in mechanical design. Organization. Imagine a huge CAD assembly of a machine. Without part numbers, finding the right bolt or bracket could take hours. Part numbers create a structured system where each component has its place. Communication. When part numbers are used consistently, communication becomes precise. A designer can communicate with a manufacturer or maintenance team without lengthy explanations. Error prevention. Misplaced or wrong parts can ruin a project. Part numbers reduce mistakes by eliminating ambiguity. Inventory management. In factories, warehouses, and service centers, part numbers make it easy to track stock, reorder parts, and ensure nothing is missing. Documentation. Drawings, BOMs, bill of materials, and CAD models all rely on part numbers. Without them, documentation is incomplete and confusing. Rules for creating part numbers. Creating effective part numbers is an art and a science. Here are some simple rules that work. Keep it simple. Avoid overly complex codes. Short, meaningful numbers are easier to remember. Use meaningful codes. Include material, size, type, or version if necessary. Avoid duplicates. Every part must have a unique number. Use a consistent format. Stick to one style across the company. A well-designed part number not only identifies a component, but also gives clues about it. Types of part numbers. Sequential numbers. Simple numbering like 001, 002, 003. Good for small projects, but can get confusing in large assemblies. Coded numbers. Include information in the code. Example B10 M8 SS for a bolt. Hierarchical numbers. Part of a larger assembly showing parent-child relationships. Example 100, 200, 001 might mean assembly 100, subassembly 200, part 001. Smart versus dumb numbers. Smart numbers give information in the code itself, like size, material, type. Dumb numbers are purely sequential, with no embedded meaning, relying entirely on documentation. Both have advantages depending on the application. Practical examples in design. Imagine designing a conveyor system. You have shafts, gears, pulleys, and bolts. Shafts could be S001, S002. Gears could be G01 20T, where 20T means 20 teeth. Bolts as B10 M8SS. Now, assembling or maintaining the conveyor is straightforward. If a gear fails, you just check the part number and order exactly the same one. No guesswork, no risk of errors. Integration with CAD, PDM, and ERP systems. Modern mechanical design relies heavily on software. CAD, computer-aided design, PDM, product data management, and ERP, enterprise resource planning, systems all use part numbers to link everything. In CAD, each part number is tied to a drawing. In PDM, part numbers track revisions and versions. In ERP, part numbers connect to procurement, inventory, and manufacturing. This integration ensures that from design to production to maintenance, every component is traceable and accountable. Common mistakes and how to avoid them. Even experienced engineers can make mistakes with part numbers. Common pitfalls include duplicate numbers. Two components with the same number can cause chaos. Overcomplicated codes. Long, confusing numbers are hard to remember and prone to errors. Inconsistent updates. If revisions aren't updated properly, old or incorrect parts may be used. The key is discipline. Maintain a central registry, follow consistent rules, and review part numbers regularly. Best practices for part numbering. Maintain a central registry, a single source of truth for all part numbers. Follow standards, ISO, company standards, or industry norms. Use revision control. Include revision numbers in part codes if a part changes. Train the team. Everyone must understand the system. Regular audits. Ensure numbers are consistent, unique, and meaningful. Impact on industry and career. A good part numbering system does more than organize parts. It speeds up design, reduces errors, ensures efficient procurement, and simplifies maintenance. For a mechanical designer, mastering part numbers is a sign of professionalism and expertise. Experienced engineers know that a well-structured part numbering system can save weeks in design, assembly, and troubleshooting. So, whether you are designing a small machine or a massive industrial system, remember this: the right part number, assigned the right way, is not just a code, it's a key to efficiency, clarity, and professional excellence. Start implementing part numbers today. Organize your assemblies, prevent errors, make your design smarter. Because in the world of mechanical engineering, clarity is power, and part numbers are the map that guides every engineer to success.